Hi everyone, so welcome to my class. It is going to be continuous random variable, lecture number you can say 17, but on continuous random variable it is going to be lecture number second, right? So I gave you the kind of introduction. I believe many of you might have enjoyed the introduction part. How do we motivate about continuous random variable? How we make transition from you can say discrete random variable to continuous random variable. So in this session, I'll talk about further concepts, right? So till now we have discussed the probability density function, which was not the probability, okay? That was probability density function, or you can say probability per unit of the you can say parameter of interest, okay? Per unit of the random variable. Understand? So if you integrate that you can say the probability density function, you're going to get the probability, right? So area under the probability is known as area under the probability density function is known as probability, right? Okay, so let us move ahead. So this is a simple idea, right? So this is lecture number 17, and okay, so today we will talk about one of the very important concept, okay? That is nothing but cumulative distribution function. Now the question is why we are talking about cumulative distribution function, CDF we call it, okay? See, when you want, if the random variable is continuous, right? If the random variable is continuous, okay, so what you're going to do, you're going to compute the area under the density function, okay? To compute the probability, you have to always integrate area under the function, right? Area under the density function, you can see. You have to find the area under the density function. So we need to figure out some other ways of finding probabilities, right? Which can directly give you the information related to probability. Why to go for area under the density function, right? Can you imagine like this? Okay, so there is a concept called cumulative distribution function, sir. Cumulative distribution function, okay? So the idea here is what? If you want to answer the probability questions, right, you don't have to integrate now. You can directly tell, yeah, this is the idea, right? So you can just go through this, okay? See, this is what I wanted to say. We will talk about CDF. In short, we call it CDF, right? Cumulative, you can say distribution function. Cumulative distribution function, okay? Cumulative, okay? Capital PDF also you can say capital PDF, or you can say that the notation wise, if you see, notation is gonna be fx of this capital F, okay, capital F, okay? So we are talking about CDF for the random variable capital X here, right? And capital later we are going to use to represent cumulative distribution function, right? So how we are going to motivate it? See, having a probability density function is fine, or you can say great, but it means we are going to have to solve an integral every single time we want to calculate the probability, okay? I believe you understand this, okay? So to avoid this unfortunate fate, we are going to use a standard called cumulative distribution function, sir. We are going to talk about cumulative distribution function, okay? And the CDF is a function which takes what? CDF is a function. CDF is nothing but a function only, cumulative distribution function, which takes in number and returns the probability. Which takes some number and returns the probability that the random variable takes on value less than that number, okay? So I will show you the representation, okay, how to define, what is the definition. But you read this. What is CDF? CDF is a function which takes in a number and returns the probability, okay, gives you the probability that a random variable takes on a value less than that number. Means the inequality that we are going to use here is x less than or equal to small x, okay? And it has pleasant property that if we have CDF for a random variable, remember this, if in the question, right, CDF for the random variable is given, so you don't have to integrate to answer the probability question, sir. This is the idea behind CDF, you can say. Okay. Just like in case of discrete random variable, you might have seen that we talked about probability mass function. So you have to just sum, right? Just to compute the probability. Okay. Summation is very simple task. But integration, when it comes to continuous random variable, right? So you have to integrate all the time to compute the probabilities, right? If probability density function is given. But suppose in the question they have mentioned that it is a CDF, cumulative distribution function. Sometimes remember in some of the books or some of the teacher also teach you that for continuous random variable we call this as probability distribution function also, right? But please remember this is cumulative distribution function. You can also say probability distribution function, right? It depends, but both are same only, right? Probability distribution function is a probability only, cumulative distribution function is a probability. So if cumulative distribution function will be given in the question, so you don't have to integrate then. Okay, forget about integration, right? Forget about integration. So I think this is clear for all. Yeah. And how CDF and your density function is related, that we will discuss. Understand? That we will talk about it. So I believe this is fine for all. Yes. So CDF definition क्या होता है sir? CDF definition is nothing but how do we define CDF mathematically? So mathematically, okay, CDF is defined as F, capital F, we are going to use it, okay, capital F, remember capital F for CDF, cumulative distribution function, right? We are talking about random variable capital X, okay, so capital F is for capital X, it takes the value small x, the random variable takes the value small x, is nothing but the probability of the event the random variable takes on, the value less than this number small x. This is a very simple definition of cumulative distribution function, one of the very simple definition you can say. Okay, and this definition is valid for continuous random variable. This definition is valid for continuous random variable, sir. Okay, so if in the question the CDF is given, right? CDF is given, okay, please remember that. Okay, CDF is given, so you don't have to compute probable area under the density function or something. You directly say that, yeah, this is the probability. What I mean to say here is, suppose someone is going to give you what is fx2, so you can say that this is going to be x less than 2. Okay, please remember this point. Okay, so this is nothing but a cumulative distribution function. Okay, what is this? This is nothing but a cumulative distribution function. Okay, so cumulative distribution function is defined for continuous random variable. It is defined for, you can say, okay, so CDF is defined for, CDF is defined for continuous random variable as well as discrete random variable. Okay, I think you may not be familiar with this fact. Okay, so the definition this till this point, the definition is gonna be same, right, for continuous as well as for discrete. But in case of discrete, suppose probability mass function is given, so in order to compute this, you can relate this with the, suppose density function is given and you have to compute the CDF. So you have to integrate this, okay, from lower bound x to upper. Okay, I will talk about it. See, देखो. So if the random variable is, if the random variable is continuous, let's say, right, the random variable is continuous for continuous random variable. For continuous random variable. Okay, I will take some of the popular density function after this discussion. Wait for that moment, and we will try to compute each and everything, right? Okay, so for continuous random variables, the density function is distribution function is defined as the cumulative distribution f of x is nothing but, it is defined as the probability of x taking the value small x, and this is nothing but an event, guys. Okay, event. And as long as the density function is given, right? Suppose density function is given, so you can just, what is the lower bound here? What they are trying to say here is some small value is, you can some number is there x, and we have to find the probability less than x. What is the lower bound here? The integration is going to be running from minus infinity to x, and here this will be the density function. You can choose any dummy variable, tau, t, x, whatever, right? So this is nothing but the relation between the CDF and the PDF, the density function. Okay, if density function is given, you have to compute the probabilities, you have to integrate it, and that will also give you the CDF. Okay, if you're going to integrate from minus infinity to x, so that will give you CDF. Okay, from minus infinity to x. Understand? Okay, so suppose you have to compute, suppose, let me take one example here. Suppose you have to compute probability of, okay, x less than 4, probability of x less than 4. So what we can do here is we can divide this interval into, suppose we can also divide with 3 and 4. So we can divide this interval as probability of, okay, x less than 3 plus, means starting from minus infinity to 3, then plus the probability of this x lying between 3 to 4. Okay, I mean x, this must be greater, you can say greater than, okay. So this is how we can write it. Okay, so we can divide into chunks. Okay, so if PDF is given, the density function is given, you can find CDF by integrating from minus infinity to x, the number that the random variable takes. And if you're going to differentiate, differentiation of CDF is nothing but what? PDF, sir. PDF means probability density function. Okay, remember this point. Okay, probability density function. Okay, so if you're going to differentiate what? CDF, which is going to give you a small, okay, you can write like this also, dy by dx CDF is going to give you a small PDF, that is density function. Okay, okay, so density function is denoted with the help of small f, small letter f, and CDF, the distribution function, right? Distribution function. Why we call it cumulative distribution function? Because we are accumulating the probability from minus infinity to x. We are accumulating. Okay, we don't have to forget the past events probabilities, right? Probability of happening past event. Okay, we have to add all the events probability. Cumulative. Okay, cumulative probability we have to discuss. Understand? So I think this is clear for all. Okay, so this is the basic thing that you can remember, right? And for, you can say for discrete random variable, if something is discrete, for discrete random variable. Okay. For discrete random variable, see, most of the time we talk about PDF. Okay, like, sorry, CDF, right? Cumulative distribution function for continuous random variable, because if CDF is given, right, directly we can compute probability. In case of discrete, there is no need of CDF and all, okay, but because there is the PMF and we can easily compute the probabilities, right? Okay, but it's okay. For the sake of completeness, we can define for discrete random variable. Okay, for discrete random variable, the CDF is defined like this. Till this point, the definition is going to be same. But now here we are going to use summation, right? Summation over, probability mass function here. Okay, probability mass function where k is less than small x. Okay, this is the definition. So you see what is the difference between continuous random variable and discrete random variable, right? Okay, what is the difference between continuous random variable and discrete? So you have got the PMF and you can get the CDF. So in case of discrete, okay, you are going to get staircase kind of connection, staircase kind of structure, staircase structure you are going to get. Okay. So wherever staircase structure is given, right, is this kind of structure I am talking about. You have to understand that we are talking about discrete random variable. Okay, this structure is not for continuous random variable. So you can imagine what your CDF, since it is known as cumulative distribution function, so it will never decrease. क्योंकि आप जैसे जैसे आगे बढ़ोगे तो your probability is gonna increase only, and it will reach up to 1. The maximum is 1, right? According to the axioms that we know, right? So your CDF, the property of CDF says that it is non-decreasing function. It can never decrease. It will be always increasing. You see here, it is always increasing. Okay, it is always increasing. Understand? So we can quickly take this example as well, right? For discrete case, let me take one example. Suppose we have got a PMF. P of x is given and the random variable takes the value 1, 2, 3, 4. 1, 2, 3, 4. PMF is given, right? Okay, you can find the PMF, I think, by defining the random variable and corresponding probabilities, right? So 1, 2, 3, 4, and here the corresponding probabilities are also given. That is 1 by 4. Here 1 by 4, here 0. Okay, and then 1 by 2, and this is 1 by 4. Okay. Now we can draw what? We can draw the CDF for the discrete random variable, sir. Since PMF is given, so we know that this is nothing but what? This is going to be, you can say, k only, no problem. K. Okay, here x is taking the value small k, you can say. So now you see till 0, till 1. What is the total sum? There is nothing. You can see here, there is no 0 probability till 1, right? So it will be 0. But at 1, there is 1 by 4. So we have to capture that. In case of discrete random variable, we have to capture equality also, because k less than or equal to x. The definition that we are applying is this: k less than equal to x. So till x, the probability is 0. So we will represent it by 0 only. You see, till this point. Okay. But now at k equal to x, there is a jump. You have to show like a jump, right? You can say this is 1 by 4. Now again, if you move further, so k till, if k is lying between 1 to 2, right? So nothing is there, right? So you can say it will be 1 by 4 only till 2. But at 2, k equal to 2, right? Nothing is there, so it will be continuous, right? It is continued. Till 3, it will be 1 by 4 only, right? Then at 3, it is going to be added up, right? So 1 by 4 plus 1 by 2, which is nothing but 4, and then 1 plus this is 2, 3 by 4, right? So it is going to be jump. ये 3 by 4 आ जाएगा यहाँ पर. Okay, so there is a jump of how much? 1 by 2, whatever probability is corresponding to k equal to 3, right? See, we are adding, we are accumulating, okay, all the probabilities corresponding to the random variable that takes it, whatever value it takes, right? You see, so it will never decrease, remember, right? Just like probability density function has the property, it is always non-negative. It can be 0 or it will be always positive, right? So in case of CDF also you have to remember, right? So you can always construct CDF, PDF, right? Whatever is given. Okay, life is very simple. Now it will be 3 by 4 only, guys. Now what you have to do here is it will be till 4. It is gonna be same. But now 1 by 4 again you have to add. So if you add 1 by 4, it will be 1 then. Maximum it can be 1. Maximum. It is 1. So ये क्या है? 1 by 4. If you add all these things, you will get 1. Keep track of it. This is the staircase structure. And by looking at the staircase structure, we can claim that this is nothing but a discrete random variable CDF. Okay, so CDF is defined for both. In our GATE coaching paradigm, nobody teaches you all these things. Let me frankly tell you, okay, because I have also taken coaching right before 10 years back, okay, understand, and I know what kind of teaching methodology is there. The same content is being repeated again and again. So whenever you will watch this session, right, you might find it innovative and kind of, you can say, highly motivating concepts, right? Okay, you see how I'm motivating these concepts, right? So CDF is defined for continuous random variable. CDF is defined for, so how do we recognize? By looking at PDF. See, if the random variable is continuous, matlab it should be described with the PDF, right? Density function. Otherwise it is not continuous. इसमें PMF दिया रहेगा. PMF से आपको कैसे ये करना है आप देख लो, सम करके, है ना? Okay, how we are getting this, right? You have to understand, we are using this summation where k is less than x. Okay, so this is one example. We will take a continuous example as well, okay, very soon. But we need to discuss some of the standard density function first, then we will take that. Okay, so let us talk about some of the general properties first. Okay, general CDF property. General CDF properties. What are general CDF properties, right? So you can say that from the definition itself, this definition itself is a property, right? You can say, right, f of x, the probability it takes less than the number, right? Okay, understand? So the very first property, it is always non-decreasing, right? It is non-decreasing. Okay, the CDF, the cumulative distribution function, is non-decreasing, right? What is the meaning of non-decreasing? If suppose by is greater than x, if the number by is greater than x, okay, if random variable takes the value by greater than x, it means that the CDF we are talking about for the random variable by, CDF, sorry, we are talking about random variable x, but it takes the value by must be greater than, okay, ये याद रखना, मतलब मेरा कहने का मान लो ये रियल लाइन है and this is x and this is y, okay, so if y is greater than x, so your CDF for the random variable x which takes the value small y should be greater than the CDF for the random variable x which takes the value small x. ये पॉइंट याद रखना सर. See, CDF is same, okay, like CDF is meant for random variable x, but what value random variable takes? If the random variable takes larger value, the CDF is going to be larger, right? CDF is going to be larger, okay. So मान लो x tending to infinity है, positive infinity, so your CDF is going to be tending to 1, tending to 1 as x tending to infinity. That is fact of life, right? Since the CDF is of direct, you can say probability only, right? In terms of probability, it is defined, okay. And your CDF tends to 0 as x tend to minus infinity, sir, because nothing is going to be, it is impossible event, you can say, kind of, yeah, okay, it is impossible events, okay. So these are the properties that you have to remember, okay. And the relation between CDF and PDF, both are, like if you differentiate CDF, you can find density function. If you integrate density function from minus infinity to x, the value that random variable takes, integrate that density function, you will get the PDF, CDF, okay. So ये सारी चीजें आपको पता होनी चाहिए. The way I am orally telling you, right? So orally you should know all these things. If you don't know orally, then there is a problem in life. Okay, and there is no excuse at all. If you don't learn all these things, there is a problem in the life. Remember, if you want to get good rank in India, you have to learn these things in this manner, guys. So though many toppers got the rank, okay, fine, but this is the right way, because when you will go to IITs, right, or ISC to pursue your masters, right, again you don't have to work so hard over there, because you have studied already the way probability and statistics should be studied, okay. And the requirement, my lectures are according to the current requirement, not only they are meant for GATE. Remember, in GATE you will be able to solve all the questions, but you have to remember these points, yeah. So as long as the definition is concerned, I define, right, okay, okay. So this is very important to keep in mind this, right? So as you have seen this sort of definition, let me put the definition again for CDF, for continuous random variable. यहाँ पर आप कैपिटल X लिख लो, कोई दिक्कत नहीं है, since in some of the books they haven't mentioned like this, yeah. And you see, so you see guys, here whenever they are asking you to compute CDF, distribution function, so you are finding the probability that the random variable takes the value less than that number, right? Why we are taking less than that number? That is the question. If someone is going to ask you why we take always, why the definition is like this, why we take x less than or equal to small x, in the definition, okay, in regular definition, whatever definition you are seeing, ठीक है, कभी आपने ऐसा सोचा है क्या? You never thought like this, yeah. Okay, so why is the CDF the probability that a random variable takes on a value less than the input value as opposed to greater than? See, you are giving x as an input, and the probability that you are going to find is a capital X less than small x. Why we are not defining it with the help of greater or kind of? Okay, can you answer this question? Have you ever thought about it? So it is a matter of convention, guys. Okay, It is a matter of convention, right? Remember this point. Okay, ये कुछ पॉइंट्स हैं जो आप बता सकते हो. Some question I will take very shortly. Okay, so you can read this, but don't write these things in your in your notebook. Okay, just write the definition. I will give my notes. You guys can go through it as a book, right? But don't don't waste your time on writing these snapshots that I am pasting here. Okay, many students, what they do is they write all these things also. देखो ये जो paragraph है ना, you don't have to write it. It's just for the sake of motivating you, I'm telling, right? That's it. So why the CDF of the probability of the random error takes less than the input value? Okay, whatever input value the random error takes, right? It is a matter of convention, but it is useful convention. Most probability question can be solved. ये लाइन बहुत याद रखना भाई, ये लाइन बहुत इंपॉर्टेंट है. अब आपसे याद रखना कि क्वेश्चन में दिया क्या है सर. Whenever question will be asked, remember this point. You have to always see what they are asking, what they have given, right? So they have given, if they have given CDF, cumulative distribution function, ये practice आप टेस्ट सीरीज में करोगे, not in the final exam. टेस्ट सीरीज में इतने टेस्ट दे डालो, give so many tests so that सारा experience clear है. So most probability questions that can be solved simply by knowing the CDF and taking the advantage of the fact that integral over the range from minus infinity to infinity is 1. Okay, you know that integral over, okay, taking the advantage of the integral over the range from minus, अगर आप minus infinity to infinity integrate करोगे density function को, एंड इसको अगर आप बैक करते हो तो दिस इज नथिंग बट एक्स लेस देन इंफिनिटी, विच इज नथिंग बट व्हाट दिस एट इंफिनिटी. ओके, so few examples of how you can answer probability question by just using PDF. I'm just going to show you some examples, right? So let me take that example and write it. देखो, those example I'm just going to take. Okay, so first example, let me take. Okay, first example. Suppose they are asking, let me directly copy and paste over there. Suppose they are asking this probability query is there, right? So suppose they are asking number 1, probability x less than a, strictly less than a. So what is that? Probability of x less than a. Solution is going to go, what is the solution, sir? Solution is going to be, answer will be fxa, right? Here you can write x. So how we are able to find directly the probability? Because CDF is given, right? If CDF will be given, then you can do like this. Otherwise, you have to integrate. An integration, suppose integration you have to use, right? So you have to integrate it from where to where, right? Where to where? You have to integrate from minus infinity to a, fx, any dummy variable you can use. Okay? And this is nothing but a definition of the CDF. Directly it is a definition, sir. It is a definition, right? Now there is a trick question, sir. Second, it is a trick question, remember that. देखो, x less than a is a definition, matter of definition you can say, of CDF. But x less than equal to a, इसमें दोनों में डिफरेंस है, रिमेंबर दैट. ओके, प्रोबेबिलिटी x लेस देन a इज नथिंग बट आल्सो fx a. ये डेफिनेशन ही है ना, ये भी तो डेफिनेशन है. बट व्हाट इज द ट्रिक हियर? द ट्रिक हियर इज व्हाट? you should know that the probability x equal to a is nothing but 0. Keep in mind this. Okay, keep this in mind. Okay. In case of continuous random variable, I told you also, right? And the third question is this. अगर मान लो x greater than a आता है, third, probability x greater than a, what is the meaning of that? You can write this as 1 minus the probability x less than or equal to a, which is 1 minus fxa. From the definition, you have to just subtract 1 minus. Okay, understood? How we are able to find it? See, we can use the concept of symmetry, sir. We are using the concept of symmetry. If they are asking the question as what is probability x greater than a, okay, that will be equal to what? X greater than a, or you can add probability x less than a. Total must be 1, right? That you have to remember always. Total must be 1. Probability x greater than a plus probability x less than a must be equal to 1. Okay, so here what you can say, this is going to be this is from the total probability, right? Okay, so from here, since they are asking you to compute this, so this will become x greater than a means 1 minus, okay, I think this is clear for all, yeah? And equality inequality does not matter here in case of continuous, remember, right? Equality does not matter, right? And suppose they are asking last question of the day, suppose they are asking the probability in the interval. So ये तो definition से आएगा, FB हो जाएगा, minus करना पड़ेगा this. You see, this is the solution, FB minus FA, right? The lower and the x greater than a subtract करना है. Okay. Yeah. So how this is coming? Let me explain. देखो, मान लो तुम्हारे पास probability x less than a less than b है. So how can you write this as? You can say that the probability x less than b, right? Probability x less than b, okay, then plus what you can say, probability x less than b. अगर आप देखोगे यहाँ पर x जो है ना, x इज लेस देन b है और x इज ग्रेटर देन a, मतलब आप समझ जाओ कि a यहाँ पर है, b यहाँ पर है. तो प्रोबेबिलिटी x लेस देन a आप कर दो, ओके, देन यहां तक तो ठीक है. फिर ये वाला भी ऐड कर सकते हैं ना, प्रोबेबिलिटी x लेस देन b, देन प्रोबेबिलिटी x इसके बीच का, ओके. सो दिस इज नथिंग बट व्हाट, इसके बीच वाला. तो आई थिंक वी मस्ट टेक 1 मिनट. व्हाट आई एम ट्राइंग टू कन्वे हियर इज वेट. ठीक है, मैं क्या बताना चाहता हूँ, बेसिकली इसको प्रूव करना चाहते हैं. ठीक है, तो व्हाट आई एम ट्राइंग टू कन्वे हियर इज, मैं क्या बताना चाहता हूँ कि ये जो आया है ना, देखो यहाँ पर, तो सबसे पहले आपको करना क्या है, this is nothing but probability x less than b, right? So you can directly say fb, okay, fb, okay, and then you have to subtract this part, okay, so that you can get this total. Simple it is, okay, remember. So let me write again. I'm pretty sorry for that, okay. इसका मतलब क्या हुआ कि आप ऐसा बोल सकते हो कि दिस माइनस दिस. Okay, and what is this? This is nothing but probability x, capital X less than b, small x, sorry, capital X only, capital X less than b, uh, okay, and minus the probability x, capital X less than a. Okay, so this is important fact of life, please remember this. Okay, I think I should not write x here. Okay. In the definition, okay, in subscript we must not write x. Okay, तो ये आप याद रखना बस. ठीक है, यहाँ पर आप x लिख लो बस. ठीक है, here x, here x. ठीक है, so this is nothing but a definition only, right? खत्म. So this kind of question they might ask you, and you have to find the probability as long as the CDF is concerned. Okay, आप directly, you can directly compute the probability. Okay, you can directly compute the probability. Okay, so please remember that. Fine. So I'm pretty sorry, sometimes what happens na, I want to explain something, but yeah, that does not hit me, so it's okay. I sometimes fall in emotional, right? Emotional kind of situation. I want to explain everything, but it is not possible, right? See, as I told you, okay, so for continuous random variable, there is a distribution, okay. For discrete also there is a distribution, CDF, okay. But there is very less utility to CDF in discrete world, okay. Because there is already PMF and all, so we can do that. ठीक है, तो आप देख लेना. Now the question is, now we will talk about some of the standard, okay, CDFs. Sorry, PDF. Okay, some of the standard PDF. Like uniform PDFs, okay, and so on and so forth. And then we will try to compute, okay, then we will try to compute their expectation, and we have to understand that what is the definition of expectation in case of continuous random variable, right? So as I told you that in case of continuous random variable, the summation is going to be replaced by the integration. That's it. There is no other distinction, you can say, right, in general. Okay, so I believe all these things are fascinating for you. आप लोगों को थोड़ा सा ईमानदारी से पढ़ना है सर, ठीक है. और इसके बाद आप PYQ लगाइए, बहुत सारे क्वेश्चंस आए हुए हैं, राइट. सो व्हाट एवर आई एम सेइंग टू यू, इफ यू विल फॉलो, यू कैन गेट द आंसर क्विकली, राइट. Fine. So let me introduce some of the simplest density function. Okay, we call it, if x is uniformly distributed, right, so that can be the uniform density function, right. So the most basic of all the continuous random variable is the uniform random variable, right. So first of all, I will introduce uniform random variable, sir. You can say most basic continuous random variable is uniform random variable. Okay, in fact I have taught these things in the discrete as well. Okay, uniform discrete random variable, right, and there we have discussed the probability mass function. But here uniform random variable, the random variable is going to be distributed uniformly here, right. So what is the parameter of interest? Okay, you can say your random variable is going to take any value in the range, in certain range here, right. As long as the continuous random variable is concerned, the value it takes in the range, you can say alpha and beta. So x, in the question also they will mention the random variable x is uniformly distributed, okay, or they might say that random variable is a uniform random variable. ठीक है, and it is denoted like this. You can say that x is uniformly distributed between alpha and beta, and alpha and beta is a range. Uni is a word they might use, right? So uni means uniform. Okay, so how does the PDF look like, sir? PDF कैसा दिखता है, ये आप लोग वेट कर रहे होंगे, right? Certainly you might be waiting for that. Yeah, so most basic of all the continuous random variable is uniform random variable, and which is equal to which is equally likely to take, okay, which is equally likely means the same probability it takes, okay, in that range. Okay, same probability is gonna be there. So it takes in the range alpha and beta, and x is a uniform random variable. This is the definition. And if it has the PDF कैसा रहेगा? Analytically, or you can say mathematically, the PDF is written like this. It's going to be equal to 1 by beta minus alpha. If alpha is, kind of, you can say that greater than beta. Okay, so sorry, beta is greater than alpha here, right? So beta minus alpha, where x takes the value, right, between you can say that alpha and beta, okay, and otherwise it is 0. This is mathematical definition. I think you may not understand that how I have written this. Yeah, ये मैंने कैसे लिख दिया आपको समझ नहीं आया. Okay, but there is a trick. You have to keep in mind that the property of density function, right? The area under density function must be equal to 1. So as long as x takes the the value between alpha and beta. So if I plot it graphically, अगर आप देखोगे ना, graphically, small f of x is going to be, suppose alpha is this and this is beta. Okay, so your alpha and beta, right, is going to be like this. So what is the distance here, guys? What is the width of this rectangle kind of situation? This is nothing but beta minus alpha. So if you want to find the area under this curve, and that must be equal to 1. So if you want this area to be 1, so what should be this, you can say, k value here? 1 by, you can say 1 by beta minus alpha. Then if you multiply 1 by beta minus alpha, the height times the breadth, you will get 1. Okay, that is the idea behind that. So in the question, they might give you any sort of density function. They can give you triangular density function or rectangular density function of this kind. Okay, this is uniform. Okay, remember the x value takes any value in the range alpha and beta, and it is equally likely. All the probabilities are same, right? All the points, all the value of the random variable x, okay, you can consider as an event here. There are many events. Okay, so 1 by beta minus alpha, the constant value is going to be 1 by beta minus alpha. And मैंने आपको बताया भी है कि in the density function, if there is a constant involved, right, so you can find the area and you can equate the area to 1, get the constant. So that is the first idea. तो यही चीज मैंने वहां पर लिख दिया है बस. ठीक है. So what you have to notice here is that whatever I have said to you is this. So notice that how the density function 1 by beta minus alpha is exactly the same regardless of the value of x. Whatever value of x between alpha and beta the random variable takes, your density function is 1 by beta minus alpha only. That makes the uniform density. So why is the PDF 1 by beta minus alpha and not 1? Because the PDF is not the probability, right? That is a constant, remember. That is a constant that makes it such a that the integral over all possible inputs evaluates to 1. Whatever input you give, whatever value of x you take, the area under the density function must be equal to 1. So please remember these points. Okay. जब भी मान लो ऐसा दिया है कि x is uniformly distributed, you can say uni, u भी दिया रह सकता है 0 to 10, तो आप सीधा क्या करोगे, आपका पहला काम क्या रहेगा सर, यू कैन प्लॉट इट 0 to 10. ठीक है, ये स्टाइल है, दिस इज द स्टाइल, धीरज सर स्टाइल, प्लीज फॉलो दिस. 1/10 इसको आप लिख दोगे. 1/10 क्यों, क्योंकि इसका विड्थ कितना है 10 है, तो हाइट कितना हो जाएगा ये 1/10. सो दैट इफ यू मल्टीप्लाई, if you try to find the area, that must be equal to 1. ठीक है, in the question they have given this kind of question has been asked, right? So always remember what kind of, you have to identify what kind of density function is given. It is uniform density function. There are different types of density function, but I am giving you uniform density function at this moment, right? So if uniform random variable is there, right, so what are the things that you can discuss, right? So you can talk about notation. ठीक है, तो मैंने अभी तक क्या क्या बता दिया है ये इन वन ग्लांस आप देख सकते हो यहाँ पर. यूनिफॉर्म रैंडम वेरिएबल will give you uniform density function. Okay. And why we call it uniform, because regardless of x in that range, the probability density function is 1 by beta minus alpha only, right? It is same. Okay. It is same. That is not the probability, please remember. It is not a probability. 1 by beta minus alpha is not a probability. That is a constant that makes the area under the density function close to, you can say that 1, right? Fine. So notation wise, this is the notation. Okay. Description में क्या रहेगा आपका, a continuous random variable takes on a values with equal likelihood between alpha and beta. Parameters में alpha is a real number, right? The minimum value of the variable, you can say. Beta is a real number only, but beta is greater than alpha such that beta minus alpha is positive over there. The maximum value of the random variable that it takes. Support क्या हो जाएगा आपका, range जो है आपका x belongs to, this is support, range of support we call it, range, or sometimes we call it support. So in the question they will give you the support, okay, and you have to plot the PDF. The density function you have to plot, and this is the mathematical definition. Here you can write x, okay, and immediately you can plot it. So alpha is a minimum value, beta is a maximum value, the width is beta minus x, so the constant, this is nothing but 1 by beta minus x, so that the area of this rectangle, I think everybody knows what is the area of the rectangle, right? That must be equal to 1. Then only it is a valid CDF, right? So in the question they will ask you whether it is a valid CDF or not. So how to claim that this is a valid CDF? See, remember for GATE exam, right? GATE exam, to find the valid density function, right? First you have to check this must be non-negative, right? And second you have to check whether area under the density function is 1 or not. Okay, ये दो पॉइंट चेक करना है. These 2 points are very important, right? Okay, so I think this is clear for all, yeah? Okay, so these are the points that you have to remember. So this is one of the simplest random variable that you can say, uniform random variable, okay, where we can talk about the okay, this is very important, okay, And this is continuous uniform PDF, right? I think you might have seen the discrete version, uniform discrete PMF, right? Discrete random variable PMF. Yeah, that was nothing but from A to B or alpha to beta also you can say. Okay. फाइन सो देखो डिस्क्रीट के केस में क्या था डीआरवी में डिस्क्रीट रैंडम वेरिएबल डिस्क्रीट यूनिफॉर्म रैंडम वेरिएबल यू कैन से okay this kind of situation is there right a next will be a plus 1 you know everything right and this is suppose b what is the what will be the probability here now you can say this is a probability right so the you have to count how many samples are there between this so in case of discrete take the end point that is b and take the first point that is minus a and then you have to add plus 1 this is how we count it right so this is going to be b minus a plus 1 so that when you add all you should get 1 that is the idea so this is nothing but PMF but in case of continuous uniform random variable the situation is going to be like this between a to b इसके बीच में कितना है b माइनस ए यू सी देयर इज अ b माइनस ए प्लस 1 ये डिस्क्रीट है इसका एरिया कितना हो जाना चाहिए मतलब सो दिस कांस्टेंट मस्ट बी 1 by b minus a this is a constant not a probability or something right okay I think this is and whenever the the probability density function is constant between this range it is known as uniform density function sometimes in the exam it can be uniform it cannot be uniform also right it is a constant that's why we call it uniform otherwise if there is a x or something right triangular density function means it will not be constant okay in that support in that range okay so you have to see what they have given in the question right? So we denote this is with the help of this notation okay so I think this is clear for all right okay now the question is how do we define expectation and all that is also very important question so ये तो आपका you can say continuous random variable hai, uniform random variable they might give you generalized uniform generalized one okay generalized you can say so what is the generalization of uniform random variable sir generalization of this क्या हो जाएगा general you can say piecewise constant PDF we call it piecewise constant PDF piecewise constant PDF means why we call it piecewise because for there will be different range of supports guys there will be different range of the random I mean the random variable that takes the value right like here only alpha and beta is given between alpha and beta the random variable can take the value and the constant is same but in case of piecewise constant PDF okay for there will be different formulas you can say for different range okay, like different constant you can say the diagram is going to be like this I'm just going to show you the diagram so you can say that this kind of situation will be there and we call it piecewise okay so between a to b you can say this is a this is b this is c and then there is a d so now random variable takes these value I mean a to d right so the constant between you can say that the constant between a to b is this right and b to c is this okay and then you can say c to d is going to be like this this kind of picture will be given, or you can say you can draw it also. तो ये कैसे आप लिखोगे? मान लो ये अल्फा है, दिस इज नथिंग बट अल्फा डैश, ये आप बोल सकते हो अल्फा डबल डैश, ठीक है। तो कांस्टेंट अलग अलग है यहाँ पर, इसीलिए हम इसको पीस वाइज कांस्टेंट पीरियड, ओके, यू नो व्हेन रैंडम वेरिएबल टेक्स द वैल्यू बिटवीन ए टू बी, तो उसका क्या है? अल्फा है। when random, but area under the density function should be equal to 1 only, guys, okay. That's true. Now you can't say that alpha dash is, I mean alpha is a 1 by d minus a, that is wrong, okay. See, so there are three constant, one constant is this, one constant, there are three constant, okay. So this is also a constant PDF, but it is a, okay, it is what, the piecewise constant PDF, right? Piecewise. Why we call it piece? Because there are different range, there are different supports for which the constant, different constants are there, okay. So in the question you have to see whether it is a piecewise, or piecewise means generalized uniform PDF, yeah. Okay. So I think this is clear for all, and okay, we'll talk about expectation and everything, ठीक है। तो continuous uniform random variable में parameter, as I told you, alpha, beta, a, b, whatever you want to take, right? And you can find out the expectation, right? Okay, and so on and so forth. Fine. Yeah. So let us try to compute the expectation, variance and all those things, right, for uniform density function, क्योंकि uniform सबसे easy होता है, ठीक है। I will introduce different types of density function. We call it exponential density function, normal density function and all, right? So we will discuss the expectation, okay, expectation. How do we compute expectation of the continuous random variable, okay? What is this expectation, sir? What is expectation and expectation operator? So देखो, continuous के केस में तो आपको पता ही है, you know that. Discrete के केस में, discrete में क्या है? Expectation is nothing but summation. It takes the value small x, the priority mass functions over all x. ये definition है. But in case of continuous random variable, the expectation is going to be defined as minus infinity to infinity. Small x, since I told you ना, यहाँ पर क्या रहेगा? Summation है. Here it will be integration, and here it will be density function. ये definition. So whatever is written here, capital X, you have to write small x here. That's it. Definition is okay. Okay. So it is nothing but what? What is the interpretation here? The average in large number of independent repetition of the experiment. Okay. It is nothing but the average, mean. Okay. In large number of independent repetition of the experiment. Okay. In continuous case. Okay. And you have to make sure that this integral must be less than infinity, sir. Okay, like absolutely integrable, you can say, right? It must be absolutely integrable. Okay. So what are the properties? Properties आप क्या बोलोगे sir? Properties of expectation. Number one, if random variable is greater than 0, right, then your expectation must also be, expectation of the continuous random variable must also be greater than 0, greater than or equal to 0. If random variable lies between a parameter, between these two values a and b, so your expectation will also be lying. ये तो clear है. Between a to b. Just to eliminate options, you can use this trick, okay? And as I discussed the expected value rule, okay, to compute the expectation of the function of random variable. Now the question is, where do we use expected value rule? To compute the expectation of function of random variable, right? So to compute the expectation of function of continuous random variable, right? What we can do here is we can say that expectation of what? Expectation of g of x, right? इसको हम बोलते क्या है सर? Expected value rule. We have to use expected value rule. What is this rule? We can say that expectation of function of random variable x is going to be equal to, right, integration from minus infinity to infinity g of x and the corresponding density function of the random variable x. You don't have to extra find out the density function for new random variable by and all. Directly you can find the expectation, right? Okay, मान लो तुम्हें फाइंड करना है व्हाट इज एक्सपेक्टेशन ऑफ एक्स स्क्वायर, तो इसका फॉर्मूला क्या होगा? माइनस इन्फिनिटी टू इन्फिनिटी एक्स स्क्वायर एफ ऑफ एक्स डी एक्स. बस अगर ये दिया है, इफ दिस इज गिवन, देन यू कैन फाइंड, यू कैन इंटीग्रेट इट, राइट? दैट्स इट. And the integration limit will change according to the density function support which is given, right, or a range that the random variable takes. Linearity is okay, life is okay. Linearity of expectation, linearity तो सब जगह valid है. ax plus b, expectation of ax plus b means a times expectation of x plus b. It is okay for discrete random variable as well as for continuous random variable. Here this x is nothing but continuous random variable. Now let us talk about variance. Okay, so see, I'm giving you the definition so that we can directly start computing the expectation, the variance of different types of density function. In the exam, these things only will be asked, right? If this is a density function, what is the probability, what is the expectation, all these queries, right? The variance is simple. The definition you can recall, right? Definition is nothing but variance of x is going to be in terms of expectation, right? That is, you have to find first the distance from the mean x, deviation ka square. This is nothing but deviation, guys. Expectation of the deviation is square, okay, where mu is going to be expectation of the random variable x. इसको कैसे कंप्यूट करते हैं? माइनस इन्फिनिटी एक्स टाइम्स एफ ऑफ एक्स. ये सब क्विक होना चाहिए आपको, राइट? सो व्हाट, हाउ टू फाइंड दैट, हाउ टू फाइंड द वेरिएंस? कैलकुलेशन यू कैन डू यूजिंग एक्सपेक्टेड वैल्यू रूल. टू गेट द formula, use expected value rule. Okay. For the calculation you can say, don't write formula, for calculation. So expectation of a function of random variable x is going to be minus infinity to infinity g of x f of x dx. Very important for your communication systems, right? This formula is very important, okay, for communication system, for machine learning, okay? So please go through these topics nicely, right? So that, so यहाँ पर आप g of x को बोल सकते हो सर कि that is x minus mu whole square. So expectation of g of x, which is expectation of x minus mu whole square, is minus infinity to infinity small x minus mu whole square corresponding. Why I am saying this is a very important expected value rule, because here you don't have to find the new density function. You can use the density function for corresponding random variable x, and then that's it. ठीक है? Okay, and what is the standard deviation? अगर कोई पूछता है what is standard deviation? Standard deviation is very simple. Standard deviation is nothing but sigma x is nothing but square root of the variance. Square root of the variance is the standard deviation. And always true things related to variance is variance of ax plus b is going to be always true. A square variance of x. Constant does not affect. It is always true. Okay. And one of the useful formula that I have told you, a useful formula, always it is going to be useful formula. And this useful formula you can get from the definition itself, right? It's going to be variance of x is going to be equal to expectation of the x square. Now x square is what? The function of the random variable minus the expectation का whole square. ये फॉर्मूला आप हमेशा याद रखना सर. This always keep in mind, right? Okay. So now you can compute the uniform density function. What is the expectation? What is variance, right? Okay, and so on and so forth. So I think I need to meet in the next class only and introduce all these things, right? And conclude, okay, all these standard density function and their mean variance, okay? And then we'll switch to covariance as well, right? So thank you. We'll meet in the next session, guys. Keep learning.